In this video, we're going to take a look at creating a full category review project. The project we're going to focus on is children's cereal, and we're going to go through two key steps of the process. The first of which is clustering. So we're going to create store clusters that group the stores together based on where there is similar shopper behavior. And we're going to use those clusters to optimize the assortments individually to create the best case scenario for the retailer, the shopper, and the suppliers. So to create a new category review project, we define some basic things about the project, such as its name, the products that we want to include, in this case kids cereals, the stores, the historic data that we wish to look at, so looking at historic performance data for 27 weeks in this example. And crucially, we link into some of our other insight systems to gain additional information about transferable demand, shopper loyalty, shopper impact on different customer segmentations, and consumer decision trees. So understanding how the shoppers shop in the category in different stores and using that information to make assortment optimizations that will better meet the shopper demand. We then understand that there's a number of different tasks within our category review project, such as creating the clusters, optimizing the assortment, creating the planograms, and then assigning those planograms to stores. And we can assign these different tasks to different people, and then we click the Save button to create our project. So the first thing we want to do is to group our stores into different clusters that represent the different shopping behaviours that we see throughout those stores, and to group them based on where we find similarities in that behaviour. The clustering algorithm has some very powerful options to help us do this. It's essentially capable of looking at a number of different KPIs, whether they be demand-based KPIs or indeed customer loyalty metrics, or any combination of those measures, or indeed demographic factors as well. We can bring those together and we can set various constraints on the algorithm, such as pre-grouping by different geographies, limiting the number of clusters that the system will create, combining with other work that has been done manually on the clustering, and then we run this clustering to produce a result. If we go and look at the result now, we'll go to the review screen, and we can see that the system has actually produced two different clusters of these stores in kids cereal. And we can see that they're fairly equally divided by the stores. And to understand what differences we're seeing between these clusters, we're going to look at the Products tab. This Products tab looks at a demand index, so it's looking at where demand for particular subcategories of products is much higher in some stores versus much lower in other stores. And what we can see here is that in some stores there is definitely a preference for chocolate, and in other stores there is more of a preference for plain or variety pack, with the flavoured being fairly consistent between the two groups of stores. So this has given us a good basis for clustering, a good way to differentiate our clusters based on whether the preference is for chocolate or whether it is for plain, and we've named our clusters accordingly. We can also understand this information on a geomap, so we can understand the geospatial aspects of the clustering, and we can see, for example, the chocolate preference is represented here in red. And if I click on one here, we can see this is a store in Brighton, and actually it's a tourist store. So maybe this is parents buying their children sort of cereal that they'd perhaps normally have as a treat when they're on holiday, for example. We can also see the clusters represented as a network graph, and this is very useful for spotting outliers. So if we see a store that is a long way out from the other stores, the system actually shades this store with a dotted line to tell us that that is an outlier, and we may want to treat that store specially when we come to do our assortment optimization. Having defined our clusters, the next step in the process is to go into the SR Assortment Optimization app and go into the category review that we've just created and actually start work on optimizing the assortments based on those new cluster definitions that we just created. First of all, we'll just describe a couple of the key sort of navigational aids around the screen. There is a 4-step process to assortment optimization: optimize, review, scorecard, finalize, and we'll go through each one of those in detail. Down the bottom here, we have a secondary workflow which goes banner, cluster, and store. If I go to the cluster level, we will see the clusters that we defined in the previous step, so the chocolate cluster and the plain cluster, but these have been subdivided based on the space available in the stores within those clusters. So some stores have 5 bays of space available and other stores have 6 bays of space available. You can even go down to the store level, and the nice thing about this hierarchy is you can work top down, bottom up, and everything you do will just affect the level that you have selected. So if I have a particular store selected and I do some work on just that store, then I will see the aggregate effect at the cluster level and the banner level. Similarly, if I work from the banner level, everything I do will affect every single store. Here we have a representation of the consumer decision tree. So this is shopper insight data, which is helping us understand how shoppers actually shop the category. And we can see one of their key preferences is branded and then own brand. And within the branded segment, we can see they then decide on flavor, the subcategory level. And if we drill down the subcategory level, we can see it's typically then a choice of size. One of the key concepts to assortment optimization is the CPI. The CPI is the Combined Performance Index, and it's what allows us to describe an objective measure of product performance for the purpose of optimizing the assortment. So typically you may wish to combine things like the impact on the customer, the impact on sales, margin, profitability, volume, market sales. In this case, we're looking at a couple of key metrics. We're looking at the customer impact, so the loyalty score, and also the rate of sale, so understanding the sales contribution of the item, of each item to the category, as well as the impact on the customer loyalty. On this screen here, we can see there are principally 3 types of columns that begin with the letter C, T, and P. C is our current situation, so we can see, for example, in branded flavoured cereal, we currently have 13 products. That's out of a choice set of 15, generating just over £500,000 and consuming about 27% of the space. T is for targets, so this allows us to set targets against our consumer decision tree to represent our strategy for the category, or rules or constraints that we have from our suppliers or within the category, run an optimization, and then the system will come up with a proposed assortment. What we'll do here is we'll set a very simple rule that says in my core assortment, because I'm working at the banner level, I want 20 products. So these are products that are going to go into all of the stores in the retailer. And if I click the optimize button and press OK, the solution will choose the best 20 products that will go into the core assortment here. Okay, at the moment you can see we have quite a poor sales impact. That's because those 20 products are only consuming about half the amount of space available. Let's go down to the cluster level, and we can see each of these clusters has inherited those 20 products, again not consuming all of the space. What we can do at this point is we can then optimize each one of these clusters individually. What I could do is I could define rules against each one of these clusters, for example putting more chocolate products in the chocolate cluster and putting more plain products in the plain cluster. But actually, if I just hit the optimize all button, the system will naturally choose the right products for each one of these clusters, because those CPI scores are calculated at a granular level. So that's it. In 2 short steps, we've actually created optimized assortments. The next thing we want to do is to review those results. So if I go to the review screen here, notice that I have the products sorted on their CPI. So the best performing product is at the top and the worst performing product is down the bottom of the list. We have some other key metrics around these products, such as their contribution to the category in terms of sales and volume, their impact from a customer perspective with the loyalty score, category penetration and primary index, and also their incremental value to the category, taking into account what they may steal from other products in the category if they're additions to a store, or what they may transfer to other products if they're deleted from a store. Notice here that we have an assortment action which is based on these current and proposed flags. So this top product wasn't previously in every store, but it was actually a very high performing product. So the system recommended that this should be added to every store, and hence it was an add for some stores and a retain for others. As we scroll down the list, we can start to see other examples where products have been deleted. So this product here was previously in every store, and the system said, hey, actually, you should delete this product because there's some other product that can better fill the space in at least these 15 stores. Now, what we might want to check is if we delete this product, where is the demand going to transfer to? So if I click on this Shreddies 500 gram product, you can see actually most of the demand goes to the other pack sizes, to the 675, the 415, and the 750 if that's available in store. And actually you can see here that all those other pack sizes are proposed for all stores. So those are available for the demand to transfer to. What we may want to do is we may want to override some of these decisions. So for example, we may go down to a cluster level and we might say actually in the chocolate children's 6-bay cluster, we might say that we decide that the Honey Monster Puffs is an important product and we're going to add this product in. Notice that we have a running commentary on the sales impact and the space impact. Because we added an additional product, we're now over our space limit, so we're going to have to take out another product or reduce facings of some of the products in the proposed assortment to get to the space available in that particular cluster. Once we've concluded all of our assortment decisions, we can understand the financial impact on the scorecard. Note that the scorecard, we can look at any level, we can look at the cluster level, we can drill down the consumer decision tree, and we can understand the impact on sales, both from a sort of absolute perspective, but also taking into account the transferable demand impact. So if I look here, for example, I can see the sales impact when it's adjusted for transferable demand, and actually we're not generating quite as much incremental value for the category as the absolute impact would suggest. There are further options for reporting. We won't describe all of these, but essentially there are a number of standard reports that the system has, such as a space versus sales type analysis. You might want to look at this by supplier. You can, of course, create your own reports as well, and that's in the self-service reports option. It's very standard pivot table functionality, which makes it very quick and easy to create your own report. So I'll first start by clicking the reset button to give me a blank report, and then let's imagine that I want to look at the current number of SKUs versus the proposed number of SKUs, and what that changes as a percentage. I can drag those three metrics on, and then I might want to say, well, actually, I want to look at that by manufacturer. So I can type in manufacturer to see that by the different suppliers. And I might want to say, how is this different across my different clusters? So I can drag cluster across there, and I can see the differences in the different clusters. Furthermore, I might want the option to drill into the different brands. So I can drill into the brands here and see under Kellogg's, these are the different Kellogg's brands here. Or I might actually want to just see that as a flat table and have the supplier and the brand represented next to one another. With all these reports, once I've created them, I can output to Excel. So I just right click, select export, and there I have the data further available in Excel. Of course, I can save these reports and I can use the report definitions in the future. And what we find is that typically customers will come up with a common set of reports that they like all their category managers to use. The last step in the process is the finalize screen. This is a final review of the different assortments that we created. So we optimized assortments across 4 clusters. So we created 4 unique assortments, and we can see what the composition of these assortments is at the top here. Down the bottom, you get the list of all the products that are in each of those clusters together with their facings recommendation. The system has been following a full inventory model here. So as the system has been making its assortment decisions, it has been understanding the space available, the expected movement of the product off the shelf, the capacity of the shelf, other rules such as minimum cases, minimum facings, etc., to come up with a overall facings recommendation for each product. The final step in the process is to actually take these assortments and to apply them to planograms. And we click on the planograms button here, and what this will do is for each of those clusters, it will take the existing planogram, create a copy of it, remove the deleted products, and then either place the added products automatically into the spaces available based on their similarity to other items in the planogram, or put them in a holding area which we call the shopping cart, and then the user can manually take them from the shopping cart onto the planograms. And here we can see the system has created the 4 planograms for us, representing the 4 different clusters. Taking a look at the smaller chocolate planogram, we can see the deleted items over here in the shopping cart. We actually selected the option that enables the system to automatically place the new items onto the shelf in the space where the deleted items were removed. So bearing that in mind, we might want to take a look where the new items have actually been placed. So one of the highlight templates here is useful. In this case, the add retain template, and this shows us where the new items have been placed onto the planogram. These planograms are now ready to take into the merchandising system, and in the next video we'll see how we apply the visual merchandising rules in the SR shelf planning module.